Hi, my name is Christian, I'm the programmer of Estlcam, and this is the Estlcam beginner tutorial. In this video we will create a Tic Tac Toe game and go through the Estlcam CAM and CNC controller workflow without need for previous knowledge. The best way to learn Estlcam is to actually use it. You will find the required drawings as Tic Tac Toe zip in the video description. And there you will also find timestamps to jump to specific topics. And maybe you would like to turn on the closed captions of the video. My English is sometimes a bit clumsy. To make the game you need 3 pieces made of medium density fiberboard, MDF, and a piece of waste wood of similar size. MDF is usually brown and can be found at hardware stores, but I have chosen a more pretty, colored version. Regarding end mills you need a thin one with about 3 to 4 mm diameter, a thicker one with about 5 to 8 mm, and a pointy engraving tool. The tool type isn't important for this project. And optionally, 8 magnets, 4 felt pads, sanding paper, superglue, paint and clear lacquer. After downloading and extracting the zip file, we can get started. Start Estlcam, select menu File, Open, and open tokens.dxf. Estlcam will then ask about the length unit of this file, select millimeter and confirm. At the top you will find the tool list. And before we can start, we first need to add the tool we are going to use to the list. At the moment there's only an example tool. We click on the empty line below to create a new tool and give it a name in the name column. I will call it Endmill 3.175 mm. Actually you can choose whatever name you want, but it should make some sense to avoid confusion when we use more tools later. However, don't use brackets, they have a special meaning in Estlcam. If you like to know more about it, let the mouse rest at a header and Estlcam will display a tooltip with explanation. And with this, we will take a short detour to Estlcam's help function. Estlcam is full of those tooltip windows that pop up if the mouse rests above something. This is Estlcam's main source of help and instruction and explains every function shortly but completely. Some also contain links to videos or websites offering further information. However, you need to keep Shift key pressed to be able to click those links. Otherwise the tooltip will avoid the mouse pointer and close itself before the link can be reached. It is a good idea to deliberately read a few of those tooltips every now and then. They contain many tips that will make work easier and cannot be found anywhere else. However, the tooltips get annoying over time. Click Menu Setup, Basic Settings, and check the Show help only if F1 key pressed option. Now the tooltips won't pop up automatically anymore, but you can still make them appear by pressing F1 key. Okay, back to the tool list. Next to the name we enter tool diameter. Mine has 3.175 mm or 1/8 of an inch. It does not matter if we use a 3.0, 3 point whatever or 4 mm tool. But one tip for beginners, avoid very thin and very thick tools. 1 or 2 mm end mills break very easily, while 20 mm tools on the other hand are expensive and very destructive in case anything goes wrong. The columns Z+, depth per pass, FXY, feed rate, FZ, plunge feed rate, and S, spindle speed, are generally referred to as cutting data. This is a topic we can only scratch at the surface. There are thick table books for reference, online calculators, and many tool manufacturers also provide guidelines for different materials. And depending on tool and material, you will have more or less leeway regarding the cutting parameters. Some materials like for example aluminum or acrylic glass are very picky and can only be machined with very specific tools within very specific cutting conditions. Otherwise the tool will break or the cut quality is bad. Other materials like for example MDF or particle board are very tolerant and can be machined with almost any tool at mostly any feed rate or spindle speed. This is the reason why I've chosen MDF for our tutorial. It makes life easy. And this is the most important tip at the beginning. Keep things simple and choose easy to machine materials so you don't have to worry about too many things at the same time. Okay, let's have a quick look at those 4 parameters. Column Z plus, depth per pass. Our material has a thickness of 19 mm, and even though MDF is very easy to machine, the tool still would not survive if we try to cut 19 mm all at once. Instead, we will machine in multiple passes, and this value sets the maximum depth increment of each pass. I will use 3 mm. We could use significantly more, but I don't want to make it a challenge for weak machines. And this is also a very important thing to know. Official cutting parameters assume a very sturdy and powerful industrial machine that cannot be compared to a hobby desktop mill. And depth per pass is the one parameter where you have the best chances of achieving some compensation by reducing the value to match the machine's abilities. But on the other side, a small end mill like this does not cost much. And sometimes it can be interesting and useful to intentionally push the values until the tool breaks, just to get a feeling for it and avoid overly conservative and time-consuming settings. Column FXY is the feed rate, or the speed at which the tool travels through the material. For MDF it doesn't matter much if the machine travels at 100 or 5000 mm per minute. We mainly focus on what the machine can do without going anywhere near the limits. If you have no idea at the moment, just enter 500, but if you're sure your machine can do it, 3000 is also totally fine. Column FZ is the plunge feed rate, basically the same as regular feed rate, but for situations where the tool plunges deeper into the material. Many materials require reduced feed rates for this, but MDF doesn't care and we can use the same value. Finally, spindle speed. I will enter 24,000, which is the maximum my spindle motor can do. This column is only relevant if you have an electronically controlled spindle motor. If your motor is controlled manually or has no speed control at all, this column can be ignored. And one final thing about the tool list. It has 2 parts. The list view giving you a quick but basic overview of all your tools, and a detail view for each tool that you can access by clicking the wrench symbol. Here we can customize much more properties, but for most simple projects the list view is just fine. But as we are already here, you can check the rounded holding tabs option, and then we close the window by clicking the OK button. Now let us have a quick look at the mouse functions. If you keep right mouse button pressed, you can pan the view, the mouse wheel zooms, and a double click brings you back to a view where the whole drawing is visible. Okay, our just created tool is highlighted red and therefore selected to create new objects. Now we enable the part function to create the outer shapes of our game tokens. And as soon as the mouse pointer gets close to a drawing shape, it will be highlighted green. And when we click, the part function creates a new toolpath around the outside of our selected shape. The counterpart to this is the hole function, and this can be used to create a new toolpath along the inside of a shape. Now we have created one X and one O, and we will ignore the other tokens for now, because we actually have a little problem that we should take care of first. If we machine our tokens this way, they will be cut out completely and just lay around loosely. Sounds good, but is bad. If we do it this way, the tool may catch the part and this can happen. If you're lucky, the part is just more or less damaged. If you're unlucky, the tool breaks. So machining the part completely is not a good idea if the workpiece is just held by clamps. There are alternatives like vacuum clamping or double-sided tape, but we will do something different. We will keep the tokens connected to the board by small tabs. It adds some manual work at the end as we need to cut those tabs and sand them down, but this is far better than risking damage to the tokens or tool. For this we select all objects we created so far, enable the select function, keep left mouse button pressed and drag it over the parts. Alternatively, you can use the keyboard shortcut Ctrl A to select them all. Then we enable the tabs function and click where we want to create the holding tabs. Here to the right in the Objects Properties section, we can adjust tab length in this field. Let's set it to 8. And tab height in the field right next to it. Let's set it to 4. The little piece inside the O can also cause trouble and jam the tool, but adding tabs here is a bit tedious. They would be rather hard to remove as everything is so tight here. So let's prevent this little pin altogether. Enable the select function again, click on the cutout and delete it by pressing the delete button or pressing delete key. Then go to the drill button, enable helical drill and click the inside of the O again. Now the inside is cleared completely with no remaining pin to worry about. Okay, now we have 7 more tokens and we could just repeat the previous steps, but I'm lazy and as the remaining parts are identical copies, we can use a shortcut. Enable the select function, keep shift key pressed for multi-selection and select the outer and inner toolpaths of our O. Then switch to the stamp function and just drop the O by clicking here, here and here. Then we go back to the select function, select the X, then again the stamp function and stamp it where we want it to be. The tokens are finished, but one important thing still needs to be done. We need to select a workpiece 0. You can later fix the workpiece anywhere within the working area of the machine, but the machine has no eyes and you somehow need to show it where your workpiece actually is. For this we use the workpiece 0 point and it works this way. You select a distinctive feature of your workpiece. Very distinctive is the left front corner at the top of the workpiece. The other corners are basically equally distinctive, but left front top is tradition, well visible from the front and suitable for most applications. And Estlcam offers special functions for this corner, so whenever possible you should choose the front left corner. And later we will just move the machine so the tool rests directly above this corner. And then we just tell the machine, now you are at workpiece 0, and so the machine knows where the workpiece is. The virtual counterpart of our corner in the cam is the blue cross here. And this can be moved to whatever location you like with the 0 function. And now, in our minds, let's overlay the screen with our board, so that the blue cross is exactly at the board's left front corner. And the locations where the objects appear now are also the locations where those objects would be machined in reality if we keep the blue cross where it currently is. And this is obviously not what we want. The left tokens are all cut off, and even worse, the tool would crash into the left clamp. If we set the cross further to the left to get some distance to the leftmost tokens, it would look something like this. Better, but now with a large margin at the left, and the right tokens almost hit the clamp. We can do much better. Our board has a size of 200 by 150 mm. We enter those values in the workspace fields. And now Estlcam displays a rectangle of this size representing our board. Then we click the 0 function, click center, and now our blue 0 cross is set so that all of our tokens are perfectly centered inside the 200 by 150 mm board. And I will take again the opportunity to try to convince you to have a closer look at Estlcam's tooltips. Many functions can do much more than you would first expect, but you will only find out if you read the tooltips and play around with the function. Okay, now the CAM part of our tokens is finally finished and we can create a CNC program. Select menu File, Save CNC Program. If you do this for the first time, Estlcam will ask you about the control software you are using. Each controller has its own expectations regarding CNC programs, and this step is necessary so you get a compatible CNC program for your controller. If you have no controller yet, or just like to play around, select Estlcam Default and click OK. This dialog only appears once, and if you later like to change your preset, click menu Setup, CNC Programs, Post Processor. Now you need to select where you like to save your CNC program. And finally, Estlcam will ask how deep you like to cut, because we never specified this. Our board is 19mm thick, but we will not use 19mm, but instead a little more, for example 20mm. This will ensure our workpiece is cut out completely, even if the material is a little thicker than expected, or the machine bed not perfectly leveled. As soon as we click OK, Estlcam creates our CNC program and shows a preview. You can rotate the view by holding the left mouse button down, and double clicks will show the default views, top, ISO and side. There's also a simulation you can start here and accelerate or decelerate with the buttons right next to it. Then click OK and Estlcam closes the preview. One final thing before we go to the machine. We should also save our work as project file using menu File, Save Project. The CNC program file we just created only contains the bare commands to control the machine, but no drawing, no tool definitions, and not the objects themselves with all their properties. This is only saved in the E12 project file, and if you later want to change something, you need the project file, do the changes, and then create a new updated CNC program from there. You can control the machine with the mouse control cross, keyboard, gamepad, or handwheel. We won't go into details, but let's have a short look at each option. The arrows of the mouse control cross are split into segments to control the speed. If you click this arrow at the base, the machine will move slowly to the right. If you click it in the center, the machine will move at a medium speed. And if you click the tip, the machine will go as fast as possible. Keyboard control is enabled and disabled by the keyboard button, or by pressing the numlock key. You can then control the machine with the number pad. The keys up here select the speed level, slow, medium, fast, let's select medium, left, right, to the back, to the front, up and down. Let's change to fast, and there we go. Tip: keyboard control is disabled automatically in some situations. For example, if you enter a text or number field. This is necessary to prevent unintended movements when typing. Gamepads are a really good option to control the machine. The right joystick controls X and Y, and the left one Z. The joysticks on their own are limited to a low speed range to allow for precise motions. For fast moves, you also need to keep one of the triggers pressed. And finally, the handwheel. The joystick controls all axes from very slow and precise up to full speed. The Z axis is moved by twisting the control stick. And the axis last moved by the joystick, or any other method, is then automatically connected to the handwheel encoder, which offers very precise control. The handwheel encoder is really great and useful to touch edges and surfaces without risk of overshooting and breaking the tool. But Estlcam compatible handwheels are, to be honest, not exactly cheap and at least at the moment also hard to get. One alternative is the mouse wheel. The mouse wheel will also connect itself to the previously moved axis and also offers a sensitive and very controlled method of moving the machine. Tip: if the machine does not react to the mouse wheel, the mouse pointer is currently above a control with higher priority, for example a scroll bar. Make sure the mouse pointer rests at the neutral control, for example the preview area. Okay, now we can fix our workpiece on the machine, but don't forget to put a piece of scrap wood below it. We will machine 20 mm deep through just 19 mm thick material. And if there is no piece of scrap wood below the workpiece, the machine table will be damaged. It does not matter where you put the workpiece, as long as the tool is able to reach any location it needs to reach. Let us assume our tool can only move inside this line and is not able to go any further to the left or to the front. Now, we obviously can't put our workpiece here, because our tool won't be able to machine in this area. But we also should keep at least half tool diameter distance to the line. It won't matter for this project, but in some cases the tool needs to be able to travel around the workpiece, and then the tool would need to go significantly further to the left than possible, even so the workpiece itself is still inside the work area. It can be useful to mark the limits of the working area with a pen. Okay, we have a piece of scrap wood below the workpiece and it is tightly secured by two clamps. We open the CNC controller window, click the button at the top and open our CNC program. The list with the CNC commands can be resized with the mouse if necessary, and the preview in the CNC controller window behaves similar to the simulation. Double-clicking selects one of the default views, pressed left mouse button rotates the view freely, mouse wheel zooms, and right mouse button pans. And now we determine our workpiece 0. For this we move the tool roughly centered above the left front corner, and then down until it touches the surface. Of course we have to be careful to avoid a hard hit to the surface, otherwise the tool may break. To avoid this, we first turn on the spindle motor by clicking the spindle motor button. A turning tool is much less likely to break than a still standing one. Then we move down until a short distance above the surface. And for the last bit, we use the mouse wheel or hand wheel encoder, which gives us perfect control. Tip: once the tool touches the surface, the noise will change noticeably. I actually don't look much at all, instead I focus on the tone change to decide if the tool reached the surface. Let's listen again. This will scratch the workpiece a little, but it doesn't matter here as this area will be thrown away anyways. Okay, now we are at workpiece 0. When you look closely, you will notice that the tool is a little bit off-center to the right, but this is good enough for now. It will cause our figures to also be slightly offset to the right, but the precision of the figures themselves is not affected. Now we have to tell the machine that we are at workpiece 0. To do this, we set all axes to 0. For this we have several options. We can click the field with the left mouse button and just enter 0. Or we can click with the right mouse button, in which case it will immediately jump to 0. There are also keyboard shortcuts, buttons on the gamepad and handwheel, and so on. Now the big moment has come, and we can start our first CNC program by pressing the play button. We can also pause it at any time by clicking the button again or pressing Escape key. Especially at the beginning, you should always have the Escape key in range. If something does not go as expected, just hit Escape and Estlcam will stop. While a CNC program is paused, you can move the machine manually to wherever you want. Estlcam will automatically return to the correct location. Let's assume I'm not sure if the clamps are tight enough. I have paused the CNC program. Then I move the machine up a bit and to the back so it is out of my way and I can tighten the clamps easily. And then, without any further ado, I can just click play again and Estlcam will resume work. Okay, now that the machine is doing its job, one very important tip. Never ever leave your machine unattended. This is really important. If something goes wrong, for example a tool breaks, the remaining dull tool stump can quickly cause a fire due to friction. And this is just one of many things that can go wrong. Use the pause feature. A pause can be as long as you wish. You can even close Estlcam, turn off your computer and machine. The next day, or whenever, you can turn everything on again, start Estlcam and reload the CNC program. In this case, Estlcam will automatically ask you if you like to resume the CNC program where you stopped it. You don't even need to remember the line number. Estlcam will take care of it. All you need to do is press play again. Okay, our figures are finished, but still connected to the board by the tabs. Just separate them and sand the tabs down. If you like, you can use some clear lacquer to make the color more vibrant. Now we go back to the cam to create the inside of our game board. Menu File, Open, Board DXF. Let's begin with the 9 slots for the tokens. However, the currently selected tool in the tool list is not our desired tool, but an example tool in the first row instead. We don't want to use this and therefore first click on our tool to select it again. Then we select the hole function and click the lower left slot. Now a toolpath runs along the inside of the shape, but there's still a lot of material on the inside that needs to be removed. For this we click on the pocket button in the lower right corner and now everything inside the shape gets cleared too. Then we try the same with the slot at the upper left corner. Here we basically want the same, but no matter where we point the mouse, the desired shape never appears. The issue is caused by auxiliary lines from the construction that misguide the automatic shape detection. So we have to do this with manual shape detection. We click this button and then somewhere along the desired shape. If we now move the mouse, Estlcam will try to find a connection between the last point we clicked and the location the mouse now points to. Let's move along this line up here. Looks fine. The green preview is following a section of the shape we want. So let's click and now this part is added to our shape. And from there we follow the shape further. This looks good, but once we get here, Estlcam takes a shortcut along the inner circle. We don't want that, so we go back a bit until everything looks fine again and click there. And so we click along the shape. Until here where we suddenly can't go any further. And if we take the mouse wheel to zoom in, the reason becomes clear. There is a gap. We point at the beginning of the gap, click, jump over the gap, click again. And now everything works normal again until we return to the starting point. There we click again and now we have a manually created toolpath. Tip: this function supports undo with the back key. Let's delete this and try again. Now I have made 2 mistakes and went along the inner shortcuts here. We press back key and again back key, and now we can continue. Okay, now we have this pocket 9 times in a nice rectangular pattern. And instead of creating it one by one, let's delete the upper one again and try the tile function instead. We enable the select function, select the pocket, switch to the tiling function, and now we want the pocket 3 times in X and 3 times in Y direction, at a distance of 44 mm. OK, and done. And now we set a cutting depth for those 9 pockets. They should be 10.5 mm deep. And in contrast to our tokens where everything was at the same depth and we just told how deep we like to machine when creating the CNC program, we now have multiple depth levels and need to specify them explicitly. We select all 9 pockets, and when we enter 10.5 in the cutting depth field, this value will be set for all 9 pockets together. We don't need to do this one by one. And if we unselect everything by clicking in the void, our pockets are no longer yellow as before, but blue. Yellow is for objects with no specific depth value. Here you will be asked about it when creating the CNC program. And green and blue shades tell that the object has an explicit depth value. Okay, let's select all pockets again. I have drawn them at exactly the same size as the tokens, and if we machine it this way, the slots may be a little bit too tight and the tokens won't fit. Let's zoom in here, and if we now set a negative value in the finishing field, the pocket gets larger. We get a little more space and the tokens fit easier. Let's use -0.3 mm. The finishing field usually has the opposite function to make things tighter at first, but we won't cover this now. Now we create this recess. For this we use the part function and click on the inner rectangle, and then the hole function and click on the outer rectangle. Now we have 2 tool passes creating an inner and outer boundary for our recess, but in between is still a lot of material left. To get rid of it, we select both tool passes and click on the island button. Now everything between the outer and inner boundary is cleared too, but the area at the inside remains standing as island. Okay, we set a cutting depth of 5 mm. And then we take care of those 4 holes we later use for magnets to keep the lid on. We create them with the helical drill function, switch to the select function, select them all while holding Shift key, and then we have to think about the correct cutting depths. The magnets are 10 mm long, so we need 10 mm deep holes, and therefore we enter 10 mm in the cutting depth field. But the holes are not at the surface, they are at the bottom of our 5 mm recess instead. And therefore we need to set a starting depth of 5 mm in the field right next to it. Otherwise the drill holes will not be deep enough. Okay, here we have 4 lines we like to engrave. We select the engraving function and just click the lines. Select them with press Shift key and set a cutting depth of 1 mm. Then we need to machine the board itself, function part, cutting depth 20 mm to again make sure everything is cut out completely, function tabs, place 4 of them, again 8 mm long and 4 mm high. Almost finished. The only thing missing is workpiece 0. We again set board size here, this time 220 by 200 mm, function 0, center, and finished. We save a project file, let's call it board inside, and then create the CNC program. Okay, back to the machine. The board is again fixed with a piece of scrap wood below it. And to make things pretty and get a nice contrast, I've painted it white. Now we could eyeball workpiece 0 like we did before, and this would be totally fine, but we are here to learn and can do it more precisely. Behind the X, Y is 0 button, you will find several functions that help you find workpiece 0. And we will use the first one, touch of X, Y, Z. It asks for tool diameter, so we enter 3.175 and 8 thickness, which we will leave at 0. Now we turn the spindle motor on, move the machine to the left next to the workpiece and down. Then carefully to the right until the end mill slightly touches the left edge. Again, we mainly focus on the tone change and not so much on looking. And then we click this button to tell Estlcam that our tool now touches the left edge. And this will make the x-axis change to -1.59, because the tool is currently not directly centered at workpiece 0, but instead half tool diameter offset to the left. Then we repeat this for the y-axis. We move in front of our workpiece and then back until we slightly touch the front edge. Now we could press this button, or alternatively use the keyboard shortcut, right Gamepad bumper or Handwheel OK button. In this case, Estlcam recognizes the correct edge automatically by checking the direction of the last machine movement. Then we move up a bit to the inside and down until we touch the surface to determine Z-axis 0. We again press the button and return to the CNC program by clicking the return button. And now we have a precise 0 for all axes. Even though the machine is currently not resting directly at workpiece 0, we could start a CNC program here immediately. It makes no difference. But on the other hand, it doesn't hurt to verify everything is fine by first moving the machine to workpiece 0. We move up a little so the tool does not scrape over the surface, and enter X, Y in the command line to move the machine to X, Y, 0. And then, for example, AZ1 to move down until 1 mm above the surface. And again, my favorite hint, have a look at the tooltips. They also explain the commands you can use in the command line. Okay, looks fine. Let's start a CNC program. So, let's assume the tool broke and the machine is now cutting in the air. What do? We pause the CNC program, move the machine upwards, then we check the workpiece if there are any remains of the old tool stuck somewhere. You have to remove them because they would destroy the new tool once it comes along. Then we replace the broken tool. Our new tool will now most likely stick out of the collet a little more or less than the old one. This means, before we can continue, we have to zero the Z-axis again. We move the tool down somewhere until it touches the surface and then set Z to 0 again. X and Y do not change. We don't have to repeat the complete CNC program, but obviously need to jump back to somewhere before the tool broke. It happened at the center pocket, and now we just keep Shift key pressed and click on this pocket. It will now be highlighted red, and Estlcam automatically jumps to the beginning of this pocket. And now we just need to hit play again, and Estlcam resumes work. Okay, back to the cam. Let's create the outside of the board. Menu File, Open, Board DXF. We select end mill 3.175mm in the tool list again. Here we have 4 shallow holes for felt pads. We activate the helical drill function, click on the circles, then switch to the select function and select them all, and set cutting depths to 1mm. Then we enable the text function, click this line at its left end so the green arrow points to the right. This is important as otherwise the text will be upside down and run in the wrong direction. I want to do some advertising for Estlcam, so let's type Estlcam DE. Make it a little larger, for example 18mm. Center. Italic also looks good. And as font we use, let's see, Estlcam GO1. Depth 1mm is fine. Click OK, and the text is finished. Then I would like to add a QR code for my homepage. Menu File, Open, QR Estlcam PNG. Now this window will appear, and there we select the first button for the QR code function. We leave everything at default values. OK. And now we have our QR code, but at a totally unsuitable location. It is already selected. We enable the move function and drag it to the desired location. OK, it snaps nicely to the center marker here. I want it a little higher. Looks fine. Now to workpiece 0. We want something distinctive like a sharp corner, but here everything is well rounded. However, the corners actually do still exist as intersection of the edges. And we can take advantage of this both here in the cam as well as later on the machine. We select the 0 function, enable the intersection function right next to it, and select the left and front edge of our workpiece. And now we again have an absolutely clear workpiece 0 at the left front corner. We save the project as board outside and create our CNC program. Okay, now we machine the other side of an already semi-finished part. Here we should consider 3 things. Workpiece 0 needs to be precise, otherwise the result is displaced and looks uneven. Then we don't want scratches on the finished part, so touching the workpiece with the tool running should be avoided. And now it is also important that our workpiece is aligned exactly parallel to the machine axis, otherwise the result is twisted. Yet, I don't take any care at all to align the workpiece properly, and intentionally fix it at a well-visible angle. Instead of wasting time aligning the workpiece, we again go to the touch of functions and select the corner with angle compensation function. Estlcam again wants to know our tool diameter, and for aid thickness we enter 0.1mm, which is roughly the thickness of a piece of paper. We begin by zeroing the Z-axis. This is an optional step for this function. You can do it here, and it also makes sense to do it here, but you don't have to and can instead also use the touch of XYZ function later. We move above the workpiece and carefully down on the surface, while holding and wiggling a piece of paper between tool and workpiece. Once we feel the paper is stuck, we click the Save Point button. And with this, the Z-axis jumps to 0.1, as we are not standing directly on top of the surface, but instead on the piece of paper. And then we get to the actual function, for which we need to touch 3 points along the left and front edge of our workpiece. 2 preferably far spaced points along the longer edge, and 1 point along the shorter edge. Here all edges are equally long, so it doesn't matter at which we measure 2 points. I will measure 1 on the left and 2 at the front. We move to the left next to the workpiece and a bit down, carefully against the left edge, until our piece of paper is stuck again. And click the Save Point button to confirm the measurement. Or alternatively, press the keyboard shortcut, right gamepad bumper or OK button on the handwheel. Then we move in front of our workpiece in the area of the left end of the front edge, back until the paper is stuck, and save our second measurement. Finally, we move to the right end of the front edge and measure the third point. Estlcam has now adjusted X and Y, so workpiece 0 is exactly in our desired corner and reports the angle it measured. And at a preview, you also see that now our CNC program is no longer straight and turned exactly the same way as our workpiece. Tip: make sure to move at least the last millimeter before touching an edge at a more or less right angle towards it. Estlcam checks the travel direction of the last millimeter to decide which edge was meant. If we, for example, travel towards a left edge in this way, it would be misinterpreted as front edge because the direction of the movement pointed mainly to the back, and the result will be wrong. Okay, we determined our workpiece 0. We could go there again to check, but I skip it this time and start the CNC program directly. Next, we create the inside of our lid. Menu File, Open, Lid DXF. There we have a huge pocket, and to save machining time and show you how tool changes work, we will do this with a thicker tool. I will use one with 8mm diameter. 8mm can be a bit much for some machines and may not even fit the collet. If this is the case for you, just use something smaller. To create the tool, we again click the empty line at the bottom of the tool list. Name: End Mill 8.0mm. Diameter: 8mm. And for depth per pass I will use 8mm too, but if your machine is a bit on the weak side, maybe start with 3mm first. And for the rest we will just use the same as for our thinner tool. Okay. The new tool is highlighted red and therefore selected. Function Hole, select the inner rectangle, make a pocket and enter a depth of 14mm. Then we have 4 drill holes for our magnets. Function Drill, Helical drill, click the circle, and Estlcam starts complaining because I have tried to machine a 5mm bore with an 8mm tool, which is not a good idea. We have to machine this hole with the thin 3.175mm tool again, so we just click on it in the tool list. And now Estlcam asks us if this tool change should already apply for the currently selected helical drill or only for future new objects. We want to change it for the helical drill too and click Yes. Now the bore diameter is okay and Estlcam stopped complaining. And this way we can create the remaining 3 holes too. Back to the select function, keep Shift key pressed and select the 4 drill holes. For cutting depths we enter 13mm. This is intentionally 3mm too deep as the magnets are quite strong and would otherwise make it hard to open the lid. Now to the dimples left and right. We enable the hole function, and if we click here, it doesn't look too bad at first. But there is still material left in the transition radius that shouldn't be there. To clear this area, the tool would need to be able to travel further to the left, but couldn't as this line prevents it from doing so. So we need a shape that provides our tool with more space to the outside. And such a shape can be found on the right side. If we select this with the hole function and make it a pocket, then the transition radius is cleared properly as well. This causes additional material to be removed outside the part, but it doesn't matter as this area will be thrown away anyways. We can do the same on the left side manually. Here we select and delete the undesired hole, and this time we use the manual shape detection. Start somewhere here on the inside and follow the shape to the end of the transition radius. Then we go to the outside, left, up, right, back on the transition radius, and the remaining way to our starting point. Pocket, and now we get the same result as on the right side. A bit skewed here, but it will do the job just fine. But I delete it anyways and enable a 1x1mm grid down here. Then we can do it again, but this time a bit more tidy. So there are two options. You can already consider situations like this when drawing and add suitable auxiliary shapes like the one on the right side, or improvise with manual shape detection. I prefer proper auxiliary shapes in the drawing, and if one got forgotten, we can make up for it at any time. So I delete this again, open the drawing in LibreCut, mirror the auxiliary shape to the left, and save the file again. Then I select Menu File, Update Drawing, lit.dxf is already selected, and OK. And with this, the drawing is up to date in Estlcam. And unlike opening a drawing with Menu File, Open, the update function keeps all the objects we already created. Then we create the dimple once again, make it a pocket, switch to the select function, keep Shift key pressed, select the counterpart on the right side too, and set cutting depth to 14mm. Finally, the part itself, function part, 20mm deep, and add a few tabs. And for workpiece 0, we again use the center function. Then we save the project as lit inside and create our CNC program. Okay, now we have a CNC program with a tool change. First we take a look at the beginning of our program to check which tool we need first. Here we find required tools Handmill 8.0mm and Handmill 3.175mm. Handmill 8mm is first, we insert it and use it to determine workpiece 0. I won't show this again, you already know how it works. Then we start our CNC program and just let it run. Estlcam is now milling the large pocket, and once finished it will automatically pause the CNC program. And display a message up here that Handmill 3.175mm is now required. Move the machine to any convenient position and insert Handmill 3.175mm. This will now most likely have a different length than our 8mm tool, and therefore we need to zero the Z-axis again. For this we just move above the workpiece, down until the tool touches, and set Z to 0. That's all. Click play again and Estlcam will complete the workpiece. Okay, back to the cam for the last time. We again open lid DXF. Here I like to create Tic Tac Toe and the Estlcam logo with a pointy engraving tool. The advantage of a pointy tool is that it makes fine details and sharp corners possible. For example, this corner in the letter A, at the left a nice sharp corner made with the engraving tool, and at the right visibly rounded with the 3.175mm tool. And the logo wouldn't be possible with the 3.175mm end mill at all, it is far too thick for this. This would only work with a tool diameter of 1.5mm or less, and even then the tip of the arrow is significantly deviating from what we want. So we need to create another tool. I call it carving bit 12.7mm, diameter 12.7, and for the cutting data we just use the same as for our 3.175mm end mill. Then we click the wrench symbol, as the tool shape can only be set in the tool list detail view. Here we select engraving tool and enter tooltip angle, mine has 90 degrees. Then we close the window. Our tool is again highlighted red and selected. We enable the carve function and click on the letters and logo. Now let's have a look at a preview. Here we select the side view by double-clicking and zoom to this area. Here you have the workpiece surface. That up there are the rabbit moves between objects, which by the way you can customize by selecting menu Setup, Basic Settings, Clearance Plane, and that here are the carves themselves. And the side view also displays a red line that tells us maximum cut depth, which is 4.85mm at the moment. Our lid has a 14mm deep pocket at the other side, so with 19mm material thickness only 5mm remain. And if we allow the carves to cut 4.85mm deep, we risk that the tool breaks through at some places. We don't want to risk this. Close the preview, select all carves again and set cutting depth to 2mm. If we now go back to the preview, we see that the carves are now never exceeding 2mm depth, and the risk of breaking through the lid is gone. The areas that have been deeper before are now cleared by the tool in a meandering pattern. And the lines of this pocket clearing pattern are currently at a distance of 1mm to each other. If we machine it this way, the bottom of our letters will have a certain wave pattern. The larger the distance of the lines, the coarser, the lower, the nicer, but at a cost of longer machining time. I want the bottom to be a bit more even and return to the tool's detail view. The distance of the lines is set in the stepover field. Usually this value is set as percentage of tool diameter, which makes sense for normal pocket clearing. But I want a specific distance of 0.5mm without having to calculate the percentage value myself. And this works by not just entering 0.5, but 0.5 mm for millimeter instead. And then Estlcam automatically calculates the matching percentage value, which is 3.9% in our case. This is again one of those things you will usually only learn by having a look at a function's tooltip. But you can also use Estlcam as a calculator, because all number fields support equations. If you enter here 0.5 divided by 12.7 multiplied by 100 and press enter, you get 3.9% again. I just wanted to show this as the calculator function can come in handy sometimes and admittedly isn't described in the tooltips. Okay, back to the preview, and now the pocket clearing moves have a distance of 0.5 mm. Finally, we have 4 lines left that we create with the engraving function. They first appear crazily thick as the tool has a diameter of 12.7 mm. We select them all while holding Shift key pressed and set a cutting depth of 1 mm. And with this, the line thickness is also adjusted as Estlcam takes the pointy tool shape into consideration, and at 1 mm cutting depth we get this line thickness. Okay, we set workpiece 0 as intersection of the left and front edge again. Save the project as lit outside and create the CNC program. Okay, for the last CNC program, we once more use the corner with angle compensation function. And we again use a strip of paper to zero the Z axis. But at the edges, we now need to take into consideration that the circumference of this tool is a bit irregular. Depending on how we turn it, the distance to the edge gets more or less. We always need a lowest distance and need to turn it so the cutting edge directly faces our workpiece edge. Doing it this way is okay, and we could use the paper strip method, but measuring with the tool running is generally a bit more precise. However, we cannot use the paper strip with the tool running. This would be insanely dangerous. Instead, I stick solidly black printed labels on the edge, and now we can touch the label with running motor until we notice contact either by a tone change or a white line appearing on the label. And our workpiece will not get scratched. Okay, there are many more methods. For example, automatic electronic contact detection, which is very fast and precise, but this would lead too far for a beginner tutorial. At the end, one last thing that often causes confusion. At the moment we have 4 tools in the list. But if we open the first project file with the tokens again, all the tools we created in the meantime are gone. This is intentional. The project files exactly restore the project as it was at the time of saving. This allows to exactly recreate projects at any time without risk of surprises caused by changed tool parameters or missing tools. And if we open the last project file for the lit outside again, all our missing tools reappear. So, if you change something in the tool list, make sure to also save it in a project file or a standalone tool list using menu Tools, Save, Complete. Okay, this was the Estlcam beginner tutorial. I hope I got a balance between mentioning everything important without going too far into details somewhat right. Have a look at the tooltips, and the best way to learn Estlcam is to just play around and try. I hope you will have fun with this and your own projects, and I'm always happy if Estlcam is mentioned somewhere. You can share this video or use parts of it for your own use. Also, I'm a bit curious what people create with Estlcam. So if you made something with Estlcam, I would be happy if you leave a link to it in the comments. And at least for this video, I will try to read and answer the comments for a while.